All right. We are going to make a little video abstract for the paper on the Tale of Two Spirals. No, the Theodorus the Theodorus variation is the current title. Anyway, this is all about a spiral that you can make. As you can see, I've had some fun. I made the spiral by hand. The characteristic of this spiral is made up out of triangles. Okay, great. What triangles? So think of this as a unit distance. Then if that's a unit distance and that's a right angle, then that's the square root of 2. One square root of 2 by Pythagoras. So this length here must be square root of 2 on this triangle. And if this is 1, like this one is 1, then we have 1 square root of 2. So what's this one? Square root of 2 squared is 2, plus 1 is 3. So the square root of 3 is that distance. Oh, great. Square root of 3 squared plus 1 squared is 4. And so that's the square root of 4, or 2. So the square root of 4, square root of 5, square root of 6, square root of 7, square root of 8, square root of 9, square root of 10, square root of 11, 12, 13, 14, 15, 16, and 17. Now I actually made one more triangle, but if you do that, it starts to overlap. So the traditional spiral, according to Theodorus, stopped at 17, and the theory is because that was when things started to overlap. But of course, we can let them overlap. Now, our paper is not really about this spiral, pretty as it is. Here's a real nautilus, just for comparison. It's about what happens when you do something a little different. So I'm just going to move some of these triangles out of the way here so that I can start the process. And what I'm going to do is I'm going to flip this triangle over and this one over and this one over and line them up this way. Flip this over and flip this over and flip this over. Okay, so you can see something slightly different is happening here now. Let's continue this process. Flip it over and flip it over and flip it over and flip it over. Aha, so something different is happening with the same spiral. And that little tack is in the way now. You're getting down to brass tacks. I got to say that. Yay. Am I mixed up as to which one is next? No, I think that's the next. No, that's not that one. It's this one is next. They do go in increasing order of size. Oop, I already flipped that one. So you see something really quite interesting is happening, is that we have a gap appearing in the middle. This is the reverse root snail. I'm not going to attempt to pronounce the German for root snail. And if we place the brass tacks at the edges, it's actually exactly the same spiral. This paper will prove that, and will prove something interesting about what's going on in the middle. That ends the abstract.